All right, continuing our nerdy read-through line by line, equation by equation of this foundational paper on generalized linear models, which I'll include the link to this paper and the complete playlist in the description of this video. Right now we're going to talk about equation number 6, which is follows directly, pretty directly from equation number 4. So this is a relatively short explanation and discussion here. But let's go ahead and move to the blackboard and talk about what's going on here. So equation 6 says that letter V, that capital V, is the first derivative of mu with respect to theta. Okay, so this follows directly from equation 4, where we have the second derivative of g with respect to theta is equal to V. Okay, so let's go ahead and plug that in first. So let's start with what is V. V equals that second derivative of g. Okay. Now, what is a second derivative? A second derivative, by definition of how you take derivatives, would be the derivative of the first derivative. Okay. So the derivative of the first derivative. So I haven't done anything. I've just kind of rewrote what is a second derivative. All right. What is the first derivative of g? If I scroll up, we previously have shown that mu equals that first derivative of g. Okay, and that's something that we discussed in a previous video, and I'll include the link to that video in the description of this video. But basically, that's what I need to do. I need to plug in mu for the first derivative of g. All right, so I get V equals the derivative of mu. Okay, and that's basically what equation 6 says. So I've shown equation 6 holds based off of equation 4 and the statement that we found prior to equation 3.